If anyone of you is getting the option to admit Manish Kumar Chaudhary in the meeting, please admit him, as I'm trying, but he's still in lobby.
Ma'am, I'm already inside.
Okay. It is still showing me that it's in process and you are in lobby.
Oh,
No problem. Maybe it's a team issue. See, still I'm getting the same thing. Waiting in the lobby, Manish Kumar Chaudhary. If you are trying from another device, please cancel it. I'm getting this pop-up again and again.
ma'am, let me rejoin
Oh,
again.
okay, okay, Manish. Okay. So what? Yeah. Still, I'm getting this option. Manish, if you are trying with another device, please. So he's not in the meeting now. Another thing. Mhm. If any one of you is getting the option to admit Manish Kumar Chaudhary in the meeting, please admit him. I don't know why it's still in process and I'm getting this option again and again. Okay, here's a reminder that there was, okay, Manish, listen, it is for everyone. This is to remind you that there was one competition or something competition going on in NASCOM, that if you complete your course and give the NASCOM assessment before 15th November, you will be eligible for some prize. Means there is some competition is going on, they will apply some algorithm, they will select some candidate and they will get something beneficial, like iPad or like first winner is iPad or something like that. Okay, there are many other prizes. You can go through the NASCOM website or the FSP website. Okay, there you can find the link. But that date has been extended. Earlier it was before you have to complete your course before 15th November. Okay, along with the NASCOM assessment. Now the date is extended for 30 November, I guess. Those who have completed the course, I hope you have received the mail regarding that. So please, if you have if you have completed the course, appear for the NASCOM assessment. Okay, one benefit is you will be eligible for that competition. You may win some prize. Another thing is, if you are working, you will get you can apply for DBT. You can apply through DBT for half amount reimbursement plus that assessment fee. Another thing, if you are not working, still they will provide you the NASCOM certificate after you will appear for their assessment, and that assessment will be that assessment will give you like whatever marks you have scored. Okay, along with the badges like gold, silver, or bronze. Okay, so I guess Rajnandani, you have completed. Ritik, you have completed, and Satishi, this Chinke, you all have completed the course. So appear for the NASCOM assessment today itself, so that you will be eligible for that competition. Okay, you might win some prizes. Okay, so it's a good offer for you.
You are talking about mock assessment.
NASCOM assessment. You have already given, I guess. Ritik, you have already given, na?
Yes, ma'am. Yes, ma'am.
So you are eligible, but those who are not appeared for the NASCOM assessment, give it give it today itself, because I guess 30 November is the last date. If you want to be eligible for that competition. So they have added some good prizes like iPad or something. And they actually give prize. Okay, I like I have not participated in the course one, but one of the competition they just uh, forcefully and asked me to participate in that competition, and I actually win the 500 rupees something they have given to everyone. Okay, coupon or something like that, and it actually works. So participate in that. It's a good competition. Another thing we have learned about k-means clustering. So quickly tell me, clustering is a supervised algorithm or unsupervised?
Unsupervised.
Unsupervised. Okay. If you will broadly classify clustering, what will be those types?
Like
You-
4 categories.
Hard clustering and soft clustering, we studied about this. 4 types. It's a good, it's a good thing. Yes. What are those 4 types? Centroid based.
Centroid based, distribution based, hierarchical based, and density based.
Okay. Tell me about hard clustering and soft clustering. What is the difference between them and what are the examples for it? What are the different algorithms you can use if you are talking about hard clustering and when you are talking about soft clustering? Can anyone tell me what is hard clustering and what is soft clustering?
May I try?
Yes, Rajnandini.
Hard clustering, basically the data points completely belongs to itself, and k-means is one of the uh, category of hard clustering, and
Not
soft
category.
uh, k-means is the hard clustering
Hard clustering algorithm.
algorithm, and soft clustering is basically when data points partially uh, partially yes, and
Actually
it's
belongs to different clusters. So
yes,
basically probability we give.
yes, and C means is the soft clustering
Fuzzy C
algorithm.
means. Fuzzy C means.
Yes, fuzzy C means.
Good. Okay. We are using k-means algorithm and it's a very famous algorithm. Give me just one reason why we are using k-means. Why this k-means is popular?
Because it groups the data into different clusters.
Only two? It's up to you how many clusters you want.
I mean,
If you will define k value 5, it will be 5 cluster.
I mean, into different clusters, not not
Okay, into
limited to.
different clusters.
Yes, yeah.
That other clustering algorithm does the same thing. I told you about the time complexity. Time complexity of k-means algorithm is order of n. Means if there are n rows, they can be executed in n number of time. But the time complexity of the other clustering algorithm, it will range from order of n squared and all. It will be like order of n square and more than that. This is one of the reason we use k-means algorithm, not other clustering algorithm. Okay. Clear, everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Now, another thing is we have talked about the distance matrix. How many distance matrix we have studied or how many distance matrix I have told you?
Two.
Two I have shared in the PPT. One more distance matrix I have told you that you can study about that. 3 distance matrix, right? Can anyone tell me the name of those 3 distance matrix?
Erudition, Manhattan, and I forgot the other
Euclidean,
one.
Manhattan, and the third one.
Minkowski.
I don't remember the
Because,
third one.
Minkowski. You can search about it. Okay. These are the distance matrix when you have numerical type of data, right? But when we have categorical type of data, then we have Hamming distance as our distance metric. Okay. There may be other distance metric as well, but Hamming distance is one of the famous distance metric when you have categorical type of data. Suppose you want to find, you have two names. You want to find out the distance between those names. How you will calculate? Now you cannot use Euclidean. You cannot use Manhattan. Okay, and Minkowski, using Minkowski, either you can find out Manhattan or you can find out Euclidean. So it's the same thing. So Hamming distance will help you to find out the distance between the categorical values. So if anyone asks, maybe if you are appearing in interview, okay, or maybe in any exam, please remember that Hamming distance you can use to find out the distance between categorical values. Okay. If you want to note it down, please note it down. If you want to study about this, you can study about this later. It's a very easy distance metric. If you will study about it, you will not find any issue there. Okay. Another thing, and we have already implemented a k-means algorithm. Remember? Today we are going to study when we have implemented k-means, we have explicitly given the value of k. Now, every time if you have data set, you don't know how many clusters you will be requiring. So for that, you have different methods. Okay, one of the method we are going to discuss today. Okay, I'm going to discuss today, which is elbow method. Another methods are like Silhouette method. It's a good method. You can try it out, but we are going to see the elbow method today. Okay. Now I'll share my screen. I have this PPT. And now, how to choose the value of k? Number of cluster in k-means clustering. Okay, just give me 2 minutes. Hello, मैम क्लास में हूँ. मैम क्लास में हूँ. 4 बजे. ठीक है. कुछ चाहिए तो मेरे डेस्क से ले लेना या मेरे बैग में से, है ना? अच्छा ठीक ठीक है. Now, here you have to define the value of k. So the performance of k-means clustering algorithm depends upon highly efficient cluster. Okay, if you will choose less number of cluster, okay, and maybe your data set contains a different variety and you are selecting only 2 cluster, 3 cluster. Okay, it may happen that the dissimilar item are also falling in the same cluster because you have taken very small number of cluster like 2 or 3. Okay, so even the dissimilar data points will fall into your same cluster. And if you will take a very large number of cluster, that is also not a good idea. Okay, maybe in that case, similar things are falling into different clusters. So you have to be very careful while selecting the number of cluster. Okay, so there are different ways you can use to find the optimal number of cluster. We are going to use one of the famous method, which is the elbow method. There are other methods as well, like Silhouette. You should remember at least more than one method. Okay, so let's see the elbow method. Elbow method is one of the most popular ways to find the optimal number of cluster. This method uses the concept of WCSS. So basically, we find out the WCSS value. Now, what is WCSS? WCSS means within cluster sum of square, which defines the total variation within a cluster. Means if I have a cluster in my graph, if I have a cluster, let's suppose I have only 2 clusters. Now the data points which fall into this cluster, Okay, this is my cluster 1 and this is my cluster 2. I'll have several data points here. What we do basically in one cluster, what I'll do, I will find out the distance of each data point with every other data point. I will take the square of it and will sum all the distance. Understand this again. I will take the distance of every data point present in this cluster 1 with every data point present in the cluster 1. After taking the distance, I will square it and will take a sum of all those square values. This will become my first cluster, this value. This formula, if you will take WCSS, first cluster value I have taken. If you want to find out this value, this is about cluster 2. You will find out the distance of every data point present in cluster 2 with every other data point present in cluster 2. After finding out the distance, you will take the square of it and will sum this up. This will become my second value. And it is talking about cluster 3 as well. So let's suppose I have cluster 3 as well and I have all these values. Okay. Now, here what you will do? Here you will do the same thing. Find out the distance of every data point present in cluster 3 with every other data point present in cluster 3. After finding out the distance, take a square of those distances and sum it out. This will become this value. Now, after summing this up, this will become my WCSS value. That value we find out. Now, what we do with this value? Come here into this statement. What are the steps we follow? Optimal number of cluster. Firstly, we execute the k-means clustering on a given data set for different k values. What we are doing, we have data set. We don't know how many clusters we require. So we run our data set, we train our data set for different cluster. Let's suppose I'm training my data set. I'm running my algorithm 10 times. So for every cluster, like first time I have taken one cluster. For one cluster, it has noted the value, WCSS value. Just give me a minute. Okay. So I'm executing k-means algorithm, okay, for the same data set, but for different cluster. First time I have executed for one cluster, second time 2, third time 3, and so on. For 10 clusters I'm running. Up to you for how many clusters you want to run your algorithm. And for every time you run your algorithm, like for 2 clusters, you have run your algorithm, k-means algorithm for the same data set, you will note down the WCSS value. Okay, and you know how to calculate the WCSS value. It will be the distance of the data point with every other data point present in the same cluster. You will take the square of it and sum it out. And you will take the sum of all those values. Okay. So for with every iteration, we will note down the WCSS value. After taking out the WCS value, we will plot a curve. That curve will be between the WCSS value and the number of cluster. Like if I have one cluster, then what will be its WCSS value? If I have chosen 2 cluster, then what was its WCSS value, and so on. Okay, a curve I will plot. Now, after plotting the curve, I will get a bend point or a sharp bend point. Okay, that bend point will be my optimal number of cluster. Okay, wherever that graph which the points which I have plotted, wherever I get the bend point, that I'll take as the optimal number of cluster. Okay, now see how. See, if I have plotted a graph, here I'm getting a bend point, right? So this point is like 3. So I will take here 3 as my optimal number of cluster. Because after this, my graph is quite parallel to my x-axis. Okay, so I can take this bend point as my number of cluster, optimal number of cluster. Okay, now let's see how we can do the same while implementation. Clear, this theory part is clear to everyone? Yes. No one is saying anything. And any doubt, any question? Because now we are going to see its implementation. Okay, I'm considering no doubt. Okay. So this I have shown you yesterday, right? So before that, let's open the data set. Not this one. Okay. So I have this data set. Let me decrease its size. I hope then it will be well. So this is a live data set. Means some here what I have like status ID. If someone has uploaded a status, okay, then what type of status they have uploaded? It's a video or a photo, something like that. Okay, then status published. Let me increase its size. I hope then it's well visible. Means at what date and time the status was published. Okay, then number of reactions it has received, number of comments, number of shares, likes, love, wow, and all those emojis. Okay, these things on every status, what are the number of likes, dislikes they have received. Okay, then there are some other columns as well, which are just empty column, no values are there. Okay, so first thing what we have to do, this is an unlabeled data set, and these columns, this column 1 2 3 4 doesn't contain any value, so we can drop these columns. Okay, and then we have to select some columns which we are going to use for our analysis purpose. Okay, and we have to convert some of the columns into as per our need. Okay, so let's see how we can apply k-means here and how we can find the value of k here. Okay, if we have this data set. Now, okay. See, first thing we are reading some of the libraries. Like we are reading pandas. Okay, because we need to we are importing pandas, not reading pandas, because we need to import file and we need to do some of the pre-processing things. Okay, then we are plotting, we are importing matplotlib because we need to plot the graph, that x and y graph, number of clusters and WCSS value, that graph we need to plot. Okay, so we are importing matplotlib as well. Let's just execute these two statements. Okay, after that we are reading this file, this pd.read_csv, and I have selected this clustering folder. In this folder I have this live.csv. Okay, let's just execute this as well. And don't go with this variables. These were the earlier variables which I have executed. So my file is read live_csv successfully. After that, df.shape we used for, we use dot shape function for
Number of rows.
rows and columns. Good. Head,
Top.
Top 5 rows.
top 5. Info,
Mean, maximum, average, and so on.
Statistical information.
Yes.
Now, dot is null, dot sum. Means if it will find out the null values in the column and it will give you the sum of all those values. Okay, let's just execute this and see the values over here. I hope it's visible to everyone. See, it has given every column name along with the null values present inside it. See the last four columns, column 1, 2, 3, 4. It is showing 7050. These are the number of rows present in our data set. So since nothing was present in these columns, it is showing that 7050 are the null values present inside these columns. So since nothing is present inside it, we can drop these columns. Okay, so in the next statement, we have dropped these columns. How? df dot drop column 1, comma column 2, comma column 3, comma column 4. X is equal to means x is equal to 1 means we are talking about the column. Okay, and then in place equal to true. Can anyone tell me what is the meaning of in place equal to true? Yesterday I have explained this.
The change has to be placed in original one.
Original data set.
Original data set. Good. Okay. So let's just execute this statement as well. Now again, this info column is there. Let's just ignore this and let's see describe. What will be the describe function will give me?
Statistical information.
No, that information gives.
5-point summary.
Describe basically give you the metadata. Name of column, number of null values present there, and their data type. Remember, let's just execute this. See, the name of column, okay, along with what I have, okay, I have
Info and
executed, I
describe
guess,
you have.
info. Let me just execute describe.
Is for that what you told, and describe is for 5-point summary. Describe is for 5-point summary.
Let me just, okay. Why? Okay. Just give me a minute. Okay, I think I have told you vice versa. Information will give you the name of column metadata and describe will give you the statistical information. Okay. Now,
Yes,
this,
ma'am.
okay. Now, these are the statements to find the unique values inside a column. Okay. So I'm just skipping this out because I need to discuss that how to find the optimal number of cluster. This is nothing but I have just tried to find out the unique values present in the column and then the length of that unique value similar in the next column, maybe next column. This is also the status type column and the length of this. Okay. So let's just execute this. This is actually not necessary for you now. And then we have dropped these columns. Status ID and status published, we don't want. Okay. That what was the status ID and at what time they have published. That we don't require. So we are just dropping it out. We require only this data set. Okay. Status type. Okay. We are dropping status ID and status published. We are taking status type and the number of reaction, comments, and shares they are getting. Column 1, 2, 3, 4 also we have dropped. Okay. And apart from that, we have dropped status ID and status published. Okay. Now, just see one thing. Notice here, status type we are taking. But what is the data type of status type?
String.
String categorical type of values we have here, right? So that we need to convert. Okay, we will see how we are going to convert. One of the method you have seen while implementing decision tree. Today we will see another method. Okay. Now we have dropped this and using information and okay, let's just execute this. I think this statement is clear. Now inside this we are storing df. In X we are storing df. So this we are making as a final data set. For line number 14th, X is our final data set. Okay, after that we will make some changes and we will take that as our final data set. Till now in X we have the total number of columns. Okay. Now we have 5 rows and 10 columns, I guess. Here. Now we want to convert that status type into numerical type of data. Okay. So for that thing, we are importing label encoder. Okay, from sklearn.preprocessing. So sklearn contains this preprocessing module from which we are importing label encoder. Now, label encoder we are storing in LE. Okay, either you can see one thing is inside label encoder you put the values in the bracket and that you can use for the further processing. Or what you can do, you can store this label encoder in any variable you define, and then use LE instead of label encoder. Okay, then what we are doing, we are transforming this status type and we are storing this into this status type only. Okay, after transforming, we are storing it in the same column. Okay, so let's just execute this and then we will see the X data type. Let me see if I have here X. I don't know whether it's changed or not. Actually, it contains. Let me see status type here. See, now it contains the value like 3, 1, and so on. Okay. Earlier, it was a categorical type of data it contains. Now it contains a value like 3 and 1, numerical type of things. How? Because we have transformed using label encoder. Okay. Then if you want to check its info, status type is now of integer type. Earlier it was of string type. Okay. Now another thing, we are going to do min-max scalar. I don't know you have studied this thing while studying this libraries or the pre-processing things, that you need to scale up your data because the data set you have here, you will find, see, some values lies between like 432, 150, 204. These type of values you have, large range they have like around between 0 to 400. Okay, or 0 to 500. These rows you will also see, these have values between 0 to 500, something like that. But here in status type, you will see the values are like 1 and 3. So if you will plot the graph, you will see that they are not the values are not scaled up. The values are not actually matching. So if you need to put all these columns into the same scale. To put all the values of these columns into the same scale, we use min-max scalar. Or if you have any other library, if you know about any other library, you can use that library to scale your data. Okay, so from sklearn.preprocessing, we are importing min-max scalar to scale our data into the same scale. Okay, so we are storing min-max scalar into MS. Then we are transforming X using this fit underscore transform. And we are storing the same thing into the same variable, into the X only. So this is how you can scale your data onto the same scale. Okay, because your data is varying, your every column is varying in different values. Okay, some are lying between 0 to 5, some are lying between like 100 to 500. So they are not on the same scale. You need to map your values onto the same scale, for which we are using min-max scalar. Okay, so let's just execute this as well. I think I forgot to execute the above line of code. See, now the values are lying on the same scale. See, there you will not find any value which is lying between like 500 or something. Every value lies between 0 to 1. Okay. This is how you can place all the values onto the same scale. Every value here lies between 0 to 1. This, all those things were the pre-processing part. Now we are actually importing, we are actually going to do the elbow method. Okay, how you can do that? I hope the pre-processing part is clear. For every data set, you will require different type of pre-processing. I hope you know this thing. Okay, now see the elbow method. First of all, you need to import k-means because k-means will be applied. Okay, to every cluster, k-means algorithm will be applied. Okay, now this CS is the WCSS value. I have given a CS name. You can write WCSS if you want to remember this. Okay, this I have made an empty list. This is the symbol of list or a tuple.
List.
How you form the tuple?
Parenthesis.
Curly braces. These are also the parentheses. Curly braces. These are the square brackets, and for tuple you use the curly braces. Okay. Now, I want that my algorithm should run for up to 10 clusters. So first it should check for one cluster, then for two, then for three, and so on. Okay. So if I give a range for I in range, I want to run my algorithm. I want to iterate my algorithm for 10 clusters. I'm giving here 1, 11. Why I'm giving 11?
Exclusive.
Yes, it is exclusive. 1 is inclusive, 11 is exclusive. So it will first run for one cluster, then for two, then for three, and so on. Okay, then we are going to apply k-means on that. You know how to apply k-means. You have to mention here k-means, then the number of clusters, then the init method. Okay, and this maximum iteration, these are the default values I have written. If you want to just cut it off, you can type. Okay, these are basically the if you are first time choosing the Centroid, how many iterations you require. Default value is 300. Even if you will not mention, if you can change the value, but the default value is 300. Okay, now after that you will fit your data. Our data is in X variable into the k-means, because in the k-means we have stored all the things. Okay, then what we are going to do, we are going to store the value, whatever value we have received, into this CSS, this WCSS. This CS means I'm creating a empty list for WCSS. So what I'm going to do, whatever value I have received, I will append into my CS list, and with what I'm passing here, k-means dot inertia. Okay, so basically what it will do, whatever value it has received from k-means, it will find out the, now what inertia underscore will do, it will find out the distance of the data points with every other data point into the same cluster. It will take the square and sum it off, and after doing this, it will get some value. That value it will append here. Means for the cluster number, if I have it, if first time it will iterate, it will bring out some value that it will append to this list. After appending, it will run for the cluster number 2. Here I value will change. Firstly, I value was 1. Now I value will be 2 over here. It will execute again. Whatever value it will get added here. So suppose first time it came out as a random value I'm taking. Okay, 5. Then 5 comma, second time it will run, that second value will come over here. So on, it will run until 10. Okay, and it will append the values over here. So my CSS list is created, WCSS list is created. Now you need to plot this WCSS along with this number of cluster. Okay, how? Plt.plot range 1, 11. So range we are giving means for the X label, the range will be 1 to 11. Okay, this 1, 11, this is x-axis. Okay, range 1, 11 means at the x-axis from 1 to 10 values will be there. And on the y-axis, I am passing CS. So WCSS value will be on the y-axis. Then title I am giving, which is elbow method. On X label, it will show number of cluster. On Y label, it will show CS, and plt.show to show the graph. Okay. Now let's just execute this. I don't know where I have stopped executing my statement. I guess x dot head I have executed. Let's run this elbow method. Okay. Okay. And let's just see the plot as well. Okay. Now, see this plot we have received. Now you can take the bend point. I guess this 3 is the bend point over here. Okay. 3 is the sharp bend point. After that, I am getting quite parallel number of clusters. Okay. So I can take 3 as my cluster, whatever point. If you are getting confused over here, na, what you can do, you can take one time try to plot it with 2, another time try to plot it with 3 number of cluster, another time 4 number of cluster. If you are getting confused, I think see this 3 is the bending point. So I can take 3 as my optimal number of cluster. Okay. Now, after this, see here I have mentioned 4. So if you think this 4 is the optimal number of cluster while applying this k-means, mention here 4. Then fit your model, apply all those things. And I think this you can do. This I'm not executing. Okay. After finding out the optimal number of cluster, you can write down the k-means algorithm. You can mention the number of cluster and you can plot the number of clusters, right? Because that you have seen when you have applied this k-means algorithm. Remember how you have plotted. Explicitly, you will give the value. You will mention the init method. You will mention the random state. You will pass the values over here. Then you can plot it using this. If you think 4 clusters, so you will mention this 4 times. Let me. Okay. Okay. And if you want to plot centroid as well, you can use this line of code. Okay. This you can do after finding out the number of cluster. Clear, everyone?
Yes, ma'am.
Okay. Round parenthesis for tuple. I don't remember. Then for set, maybe we are using the curly brackets. Now, if anyone have any doubt, please ask. I will share this elbow method as well, this code and data set with you. Try, see, I have not executed that how, if I'll take 4 as my cluster, then what will, how the clusters will look, how the clusters will form, that you can do, I think. Now there are no there should not be any doubt that how to plot these clusters and or how to train your algorithm for 4 clusters after finding the optimal number of cluster, that you can do. Okay, but how to find out the optimal number of cluster, that was something new which I have told you. Okay. So now if anyone have any doubt, can ask. Another thing, tomorrow you will have a revision session on HBase. So those who have asked for it, be on time at 3 p.m. You will have HBase revision session with Sunil sir. Okay. And Spark session maybe next Monday you will have Spark revision session. Revision means you will have the doubt session. So if anyone have any doubt in HBase or in Spark, can ask. Tomorrow is HBase doubt session and Monday is Spark doubt session. Okay.
Okay, ma'am.
Just a reminder, give your NASCOM assessment today so that you will be eligible for that competition if you are interested. Okay. Bye then. Take care.
Ma'am,
Yes.
so there will be no class after tomorrow.
No, after tomorrow there will be no session. One thing I forgot to tell you, that I have still not given you the guide's name. Okay, So I will share that list. Actually, I was not getting time to make that list. So I'll segregate the project topics. Okay, I'll give you the guide's name. You can contact your guides regarding your project. Any query regarding report, regarding project. Okay, you can have meetings with your guides, and if you face any difficulty while revising the same course, you can raise that in group, okay, or in mail. We will definitely answer that, and if any meeting is required, we will conduct meetings as well.
Okay, ma'am.
Or you want to have more meetings, more classes? Yes, Atisi?
No, I mean, I'm just confirming.
Curious to know.
Yeah.
Okay. Okay. Then I think this is our last session. After that, we'll have only meetings regarding project. Okay. So bye-bye. Take care. Disturb
Ma'am?
your guides between 9 to 5:30. All the best. Bye-bye.
Ma'am, is it excuse
Yes,
ma'am,
yes, Anushka.
is it possible to post the recordings of machine learning sessions in the classroom, Google
Yes.
Classroom?
Okay.
Because I have
Okay.
not attended the sessions properly on machine
Okay.
learning.
So see, today I think it's not possible because downloading them and uploading them takes time. So maybe in 2-3 days I'll upload all the files, and then you can watch from there. Okay.
Okay, no problem. Thank you.
Just give me a minute. Hello, everyone. Yes, if you have any doubt, please ask. Anushka, I'll update in 2-3 days, and then I'll let you know in group. Okay.
Okay, thank you.
Okay.
Ma'am, is there any specific like format for the report, like acknowledgement, or do we need to have a cover page or so, or we can directly have a topic and we can start with the introduction part?
I'll share the front page and certificate page with you, and then I'll tell you the order you have to follow. Like first, what will be their acknowledgement or something like that, and what are the things that needs to be added in report. Like first will be problem statement, then objective, then literature survey, a brief literature survey. Okay, not the detailed one. Then what is the methodology you have used. Okay, then about the methodology, like if you have written any algorithm, so a brief description on these algorithms. Then the hardware or software used. Okay, so if you have used like configuration, basically you need to mention. Then after that you can mention what is the result you have received. Okay, like comparison if you have given, so all the result it should be clearly with screenshots. Okay, like whatever output you have received, so with screenshots you have to show there with accuracy or whatever measurement metrics you have used. Okay, then the conclusion and future scope. I'll give all these points into mail or in WhatsApp group. Okay, with everyone. I'll share these points, and I'll share the front page format and the certificate format. those certificate basically will be signed by, if you will get those hard copies, if you want to if you want that it needs to be signed, then Tushar sir will sign it. Okay, so if this is the case, so bring 2 copies. Okay, like I know that everyone, these are the online session, not everyone can bring it, but if you want that your reports needs to be signed, you wanted to show somewhere, maybe in college, you can bring your copies, and at least 2 copies. Once it is approved, 2 copies, one keep it with you, and another you have to submit here. Okay, it's not compulsory that you have to submit here. I know candidates are for Impal as well. Okay, so those who wants that your reports needs to be signed, and if you need digital signature as well, okay, you can send the copies. Once it is approved, it will be digitally signed. About that, about the sign and everything, I'll tell you later, but about the format, I'll send over the mail.
Okay, ma'am. Thank you.
Okay, ma'am.
Okay, bye bye, take care. Any other doubt? No. Okay, then bye bye, take care.
Thank you, ma'am.
Thank you.